Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad Muhaimi bin Zainal. Nombor kad matrik saya CB210388. Hari ini saya nak membentangkan pertanyaan yang bertajuk Manufacture Workpiece Materials that are intended for aircraft materials and their components. The first slide for introduction. 40 years ago, aluminium dominated the aerospace industry. As a new kid on the block, it was considered to be lightweight, inexpensive, and state-of-the-art. In fact, as much as 70% of an aircraft was once made of aluminium. Other new materials such as composite and alloys were also used, including titanium, graphite, and fiberglass, but only in very small quantities. 3% here and 7% there were readily available. Aluminium was used everywhere from the fuselage to main engine component. Times have changed. A typical jet built today is as little as 20% pure aluminium. Most of the non-critical structurally material, paneling and aesthetic interiors now consist of even lighter weight carbon fiber reinforced polymer (CFRPs) and honeycomb material. Meanwhile, for engine part and critical component, there is a simultaneous push for lower weight and higher temperature resistance for better fuel efficiency, bringing new, progressively impractical to machine metal into the aerospace. Okay, next, basic and supplementary theories. Metal parts are an important part of modern aircraft. In the more than 100 years that aircraft have been built, they have come a long way in terms of material, from the Wright brothers' wooden units to today's modern composite jets. Over the years, designers and aircraft manufacturers have considered a variety of factors when selecting aircraft materials, from functional requirements to minimizing production and maintenance costs. However, the main engine of progress is the desire to reduce the weight of its wearable metal machine. The reduction of this parameter is a factor that controls the level of safety of the pilot, passengers, cargo, and the aircraft itself. Its performance, optimal fuel consumption, and flight range. Today, modern engineering concepts focus on expanding the use of composite materials in aerospace engineering. Next is description and explanation. Most people at some point wonder how an airplane flies, but have you ever wondered what materials an airplane is made of? The material used to make plane wing, fuselage, and skin vary widely in reliability, and it can be fun and interesting to learn about them. Most aircraft are made of titanium, steel, aluminum, and many other materials, including composite. Composite material can contain a variety of different materials, often including polymers, carbon fiber, and the like. These metals are hard, strong, corrosion resistant, and lightweight. They are the perfect material for all types of aircraft. Okay, next, materials and construction of aircraft. Early technology. For reason of availability, low weight, and prior manufacturing experience, most early aircraft were of wood and fabric construction. At the lower speeds than obtainable, streamlining was not a primary consideration, and many wire strut braces and other devices were used to provide the necessary structural strength. Preferred wood were relative light and strong, and fabrics were normally lined or something similarly close with, not canvas as is often stated. As speed advanced, so did structural requirements, and designers analyzed individual aircraft parts for both strength and wind resistance. Bracing wires were given a streamlined shape, and some manufacturers began to make laminate wood fuselage of monocoque construction. Stress carried by the skid for greater strength, better streamlining, and lighter weight. The 1912 record-setting film races the German after later of World War I and the later American Lockheed Vega were among the aircraft that used the type of construction. Aircraft made of wood and fabric were difficult to maintain and subject to rapid deterioration when left out in the elements. This, plus the need for greater strength, led to the use of metal in aircraft. The first general use was in World War I, when the Fokker Aircraft Company used welded steel tube fuselage, and the Junkers Company made all-metal aircraft of dual tubing and aluminum covering. During the period during the period of 1919 through 1934, there was a gradual trend to all-metal construction, with some aircraft having all-metal, almost always or aluminum alloy structures with fabric cover surface, and other using an all-metal monocoque construction. Metal is stronger and more durable than fabric and wood, and as the necessary manufacturing skills were developed, is used enable airplanes to be both lighter and easier to build. On the negative side, metal structure is subject to corrosion and metal fatigue, and new procedures were developed to protect against this hazard. A wide variety of aluminum alloys were developed, and exotic metals like molybdenum and titanium were brought into use, especially in vehicles where extreme strength or extraordinary thermal resistance was a requirement, as aircraft were designed to operate at Mach 3 times the speed of sound and beyond. A variety of techniques to avoid the effect of aerodynamic heating were introduced. These include the use of fuel in the tanks as a heat sink to absorb to absorb and dissipate the generated heat, as well as the employment of exotic materials such as the advanced carbon composite, silicon carbide, ceramic coatings, titanium aluminum alloys, and titanium alloy reinforced with ceramic fibers. Additionally, some designs call for the circulation of very cool hydrogen gas through critical areas of aerodynamic heating. More reasons why titanium is added to steel in the making of aircraft are because it is almost as strong as steel, it is heat resistant, it is corrosion resistant, and last, it is a medium weight metal. Okay, for conclusion is for decade, the speed of commercial aviation was constrained by the sound barrier. Even with the Concorde flight was unavailable except on a few routes and only for those really unable to pay the high airfares. Commercially successful flight will only occur when technology is developed and assembled into an aircraft that can be profitably manufactured in large quantity, and that is affordable for users and environmentally acceptable to society at large. Commercial aircraft could take many different forms. The, the path to success will depend upon the ultimate and intermediate goals selected and the time and resources set aside to achieve them. One approach would be to focus on entirely new forms of air vehicles, such as vehicles energized by laser beam from ground power stations. A second approach would be to push push revolutionary new aircraft, such as a morphing aircraft with the ability to continuously modify the shape of its wing to optimize aerodynamic performance during phases all phases all of flight. Either approach requires breakthrough technologies and tuning new technologies into an operationally commercial supersonic aircraft is very expensive and takes decades of research and development to certify performance, economic safety, and environmental requirements for aircraft and ground systems. That's all. Thank you.